Hey folks, this is a quick little review on what to expect regarding the individual test, the final test, OB3 for the chemistry unit. Just going to run through the test to make sure that if there's any questions, they are answered in this as best as can be for anyone who may have missed Tuesday's class where I went over it. Okay, obviously you got to get your name, your period in there and so forth. First, very, very important. This is where reading comes in. Oh my gosh. Use this image to answer numbers 1 through 8. Plus, you get the periodic table of elements that you get to use when answering this also. So please note, we've got an atom here. We've got some information in this picture here, and you need to go and be aware of the particles in this atom to answer the next 8 questions. So you got a periodic table also here to help you. Don't forget you can zoom in and zoom out on your screen so you can see it better. But you're identifying the parts of the atom with the electron, the nucleus, the proton, the neutron, and yes, so that's the first 4. And then number 5, the atomic number. It's an actual number that I want you to type in the answer here and refer to the atom image above. And I'm giving you the hint of ape in ape man. Now, for 6 and 7, you get a word bank. Notice boron, K, potassium, C, carbon, N, B, and helium. You actually need to figure out from the picture of the atom up above what element this is and write down type in what its element symbol is. Make sure you use the word bank here to answer number 6 and 7, which means the answers to 6 and 7 are in this word bank. Okay. Number 7, the element's name, and number 8 is the atomic mass rounded to the nearest whole number. Definitely remember this is the man part of 8 man, but you also have the ability to look at the periodic table and round to the nearest whole number when you figure out which element it is. All right, so scrolling down here, states of matter. 4 questions. We have an increasing temperature on the left-hand side, the y-axis, and the x-axis has a kinetic energy increasing. So you need to identify the different states of matter here. 9, 10, 11, and 12. 13. 13 is a question about the kinetic energy, and if you were to move from one state of a matter to another, in this case, if you were to freeze some water into ice, would you need to add kinetic energy or would you need to remove it? No, that's based upon the graph up above. Number 14, 15, and 16 is all a way of identifying your definitions of either the characteristic properties of condensation point, melting point, and boiling point. And each one of those definitions goes with one of those points. Let's stop. You've got the chemical and physical. Quick little reminder there, the different types of chemical changes versus physical changes. You've got some examples, car burning gasoline, ice cubes melting, and so on and so forth. And so your goal here is to decide whether each one of those is chemical or physical, partly based upon what you've been learning and studying, but also as this picture helps you out. All right, moving on here again, mixtures versus compounds. So please remember that a mixture is when you put things together physically, but they never really combine chemically. So this is only physically combining. You'll notice here the red and the white or yellows here do not seem to be actually joining each other. They're just side by side. A compound, however, which is where you make new things, that's when you actually chemically combine things, and it's much, much harder to separate. And so looking at these examples, salt and pepper in a jar, hydrogen and oxygen to form water, and so forth, how would you identify those? Would those be mixtures or would they be compounds? Number 24, why would these 3 atoms want to hang out so close together that they would bond? And one of these statements will help to explain that. Do your best and make the right choice. Number 25, we have addressed this so many times, but just remember, conservation of mass is all about whether or not it's the idea that matter cannot be created or destroyed in a closed system. So you need to make a good choice here as to which one of these demonstrates conservation of mass. 26. Laura adds 50 mLs of boiling water to 100 mLs of ice water. She then needs to go and freeze it in a freezer. What temperature will the water freeze at? Make a choice. 27. You're given an unknown liquid. You need to test it in the lab to figure out what property, what element or what material it is, what liquid it is. Which one of these characteristics would you go and choose? Your choices are down below. 28. The table below shows the number of each kind of atom that makes up one molecule of the compound sucrose and ethanol. Which of the following is the same for both compounds? The chart only gives so much information, but one of these answers matches with the chart. 29, you got a picture here of water boiling from a liquid to a gas. I'm asking you, why could you not use this situation to demonstrate conservation of mass? Again, If you need to look back at an earlier question, you may do so. And last question here, number 30. How many different elements are in the compound sodium carbonate? That's Na2CO3. Or in this case here, how many of the elements in the periodic table are arranged, numbers 1 through 118? And so my question to you is, which one of these answers has the answer to both of these questions found up above? This, ladies and gentlemen, is the independent portion of your final test. Good luck.